All right, everybody. Today we are looking at being able to solve more complex linear equations and ones that are going to have some very unique solutions. So if you kind of take a quick look through your notes, we're going to be doing some problems that use the distributive property, ones that have variables on both sides, and then we're going to look at some special cases, and then I'll let you guys practice a little bit. Okay, so here's what I need you to do. You guys should know how to simplify the expressions that are found on the left side of both of these equations. So what I want you to do is for a second, just ignore what is on the other side. Just temporarily ignore. You don't need to physically cross this out. Okay, I'm just doing it so you get the idea of what I'm saying. And I want you to simplify the left-hand side of those expressions as much as possible. This should be good review. Pause, and then come back. Okay, I'm assuming you've done that by now. I'm going to bring the other side of our equation back. So in the first one, we should be distributing a negative 3. So we should get negative 18x. And since we're doing a negative times a negative, we should get a positive 6. Then distributing a positive 3 and getting 6x minus 3. And that's still all equal to negative 3. We should now combine our like terms. So if we combine all those x's, we get negative 6x, and 6 and negative 3 make 3. And now we've got a standard two-step linear equation. Okay, so I'm not going to actually show what I'm physically doing to both sides. I'm just going to show the result. So I'm going to subtract 3 from both sides. That gives me negative 6x equals negative 6. Then I'm going to divide both sides by negative 6, and I get x equals 1. Great. Good for that first one. I'm going to erase this, move on to the next one. So if you haven't simplified the left side yet, make sure you do that before you move on. Okay, all I'm doing here is distributing a negative sign, so that's going to switch the sign on both terms and make them both negative. 7 minus 5 is 2. So that's what you should have had after the simplification process. Again, two-step linear equation. Subtract 2 from both sides. When I do that, I get negative 6x equals 2. It's really important that you leave that negative, that subtraction sign. That makes that 6x a negative, so it's negative 6x equals 2. All right, and then divide everything by negative 6. I'm going to show it on this one because what you can see here is that we have like a fraction, 2 over negative 6. So just simplify the fraction and leave it negative 1/3. All right, now we're going to deal with what happens if we have variables on both sides. So again, what I want you to do is take these first two right here, and I want you to simplify, distribute and simplify both sides as much as you can, pause, and then come back. I'm assuming you've done that. I'm going to do this rather quickly. I get 45 minus 5x equals 4x plus 72. Now the only thing that you have to do that's a little bit different here is you just have to add or subtract your x's, so you only have x's on one side of the equation. It doesn't matter what side. So I have two options here. I could subtract 4x from both sides, or I could add 5x to both sides. I'm going to add 5x to both sides. Okay, and since it's addition, I don't have to like add it to both terms or anything like that. I'm just going to combine my like terms and get 9x plus 72 over here. Now, again, two-step linear equation. I'm going to subtract 72 from both sides, and I get 27. Negative 27, excuse me, when I subtract 72. Divide by 9, and I get x. I get negative 3 equals x. If you prefer to flip that back around, which I usually do, I'm going to flip it back around and make x equals negative 3. Okay, I'm doing pretty much the same thing on this next one, except the one big difference I have is that I don't really have to simplify it all on the other side. Okay, so I'm going to speed through here, and I'm going to get 3x plus 12, distribute the negative over here, combine my like terms, and again, I need to get my x's onto one side. I'm going to make this real easy on myself and subtract x. 2x minus x is 1x, which is just x. I get x plus 9 equals negative 1. Subtract 9 from both sides, I get x equals negative 10. All right. Now, there can potentially be some problems when you have variables on both sides, okay? Here are two special cases. So what I want you to do is try solving for x in both these cases, and if you get stuck at any point, you can just come back and watch. But try to do as much of this as you can on your own. You're going to see kind of a similar thing happen in both problems. Okay, so we solve this just like we would any other. I need to distribute my 3. Now I need to get my variables onto one side, so I'm going to add 9x to both sides, and lo and behold, it drops out on both sides, and I'm left with 5 equals 3. Okay, I'm not going to tell you what that means just yet. I want you to think about it, and if you think you know what it means, you can go ahead and write that down, but I'm going to move on to the next one, because I'm going to get something very similar happening down here, except down here, when I subtract 4x from both sides, I get 12 equals 12. Okay, these are two very special cases. When an x drops out like this, you kind of have to look at what's left. 5 equals 3 is silly. It doesn't make any sense. Okay, 5 is not equal to 3. What this means is that in this particular case, there is no solution for x. There is not an answer for x that will make this true, which makes sense. If you were to take, on both sides, you're subtracting 9x. On one side, you have a 5, on one side, you have a 3. There's no way to get those equal to each other. On this side, this is always true. So your answer here is going to be all real numbers. Okay, that means that you could put in any number on both sides and get the same answer, which makes sense because right after your first step, you realize that both sides were the same. Another name for this is identity. Okay, identity is a kind of a way of saying both sides are identical. Okay, so here's what I want you to do. I'm going to have you try just a few of these. Okay, these 3. What I want you to do is solve for x like normal, if you can. It is possible that you may just get a normal answer for x. Or, if you get both sides are equal to each other, write identity. If you get something that doesn't make sense, like the x's go away, but you get 5 equals 3 or 7 equals 2, then write no solution. So try all 3 of these, pause, and then come back. Okay, A, you should have gotten an answer for. Okay, because we get 4x plus 7 on this side, and we get 5x minus 6 on this side. I'm going to subtract 4x from both sides, and then I'm going to add 6 to both sides. And I get x equals 13. I get a perfectly valid solution. Over here, I'm going to distribute the 2. I don't have to do anything over on the other side. That's a 2, by the way, a very bad 2, because I wrote it as a 1 first. I'm going to combine my like terms, and I get 2x minus 2 equals 2x minus 2. If I want to subtract 2x from both sides, I'm going to get negative 2 equals negative 2. This is something that's always true, so this is an identity. Okay? Finally, let's do the last one. I'm willing to bet you guys can probably figure out what this is going to be. Okay? So, last one, then we're done. Distribute the 4. Okay, combine. Oops, 2x plus 4, excuse me, equals 6 plus 2x. When I subtract 2x from both sides, I get 4 equals 6. That means I have no solution. I'm just going to write NS. Okay, so these are how different linear equations could become potentially a little bit more complicated. So write a nice response to this. Ask a good question. You may have some after this one. Hope everybody learned something.